In section 7.1, you learned how to solve a system by graphing, where you graph two lines and identify the point of intersection. In 7.2, we learned how to solve by substitution, but in order to do that, one of the variables had to be isolated. So in this section, we're going to be learning how to solve by eliminating a variable. The first way is just by adding or subtracting. 7.4 will be what happens when you can't add or subtract. So we already know how to solve a system by graphing and substitution. Graphing, if you're doing it by hand, can take a while, and substitution, if a variable isn't isolated, requires more steps. So our goal today is to eliminate a variable. So if we look at these first two equations, I want to try to get rid of one of the variables. My only choices are adding or subtracting. So I'm just going to draw a line here, and the question becomes, can I add these equations or subtract them from each other to get rid of one of the variables? And you want to kind of look for matching coefficients. So 2x and negative 2x are pretty close to matching. Since they're opposites, what I can do is add, and I'm going to put this in parentheses for right now. So then if you add 2x plus negative 2x, that actually completely cancels out. And then if you add, because 2 plus negative 2 is 0, then if you add 3y plus 5y, you end up with 8y. And then if you add 11 plus 13, you end up with 24. So by adding those equations together, I've completely eliminated the x, and I end up with only y. Now I can solve for y by dividing by 8, and I get y equals 3. To find the x, I can take that y equals 3 and plug it back really into into that y right there or that y right there. I'm going to choose the top one just because there's no negatives. So I'd have 2x plus 3 times 3 equals 11. So then I would have 2x plus 9 equals 11. If you minus 9 from both sides, you get 2x equals 2, x equals 1. So your final answer would be 1, 3. If I go to the example below, 4x plus 3y equals 2, 5x plus 3y equals negative 2. So on this one, my matching coefficients are really my y's, 3y and 3y. So to get rid of a y in that case, I'm going to minus. So I'm going to put a minus here, and again, I'm going to put parentheses because I'm really minusing every single piece. So 4x minus 5x would be negative 1x. 3y minus 3y would cancel out because that's 0. So then I bring down my equal sign. And then 2 minus negative 2 would be 4 because it would be plus positive. So then x would equal negative 4, and then I could take that and plug that back into either equation. So if I plug it into the top equation, I would get negative 16 plus 3y equals 2. If you add 16 to both sides, you get 3y equals 18, y equals 6. Final answer, negative 4, 6. One thing you just want to be careful with is, especially your signs. So when, for example, 2 minus negative 2, that became a plus positive. And just the idea that you're really subtracting or adding every single piece. You don't actually have to draw the parentheses in, but just to kind of show that it's happening to every piece and not just the 5 and not just the negative 2x is helpful. So you're going to try this example here, 3x plus 4y equals 8, and then this one down here by either adding or subtracting. Pause the video, press play when you're ready to check your answers. So on this example, you want to add to cancel out your x's. And then 4y plus 5y is 9y, 8 plus 10 is 18, so you get y equals 2. And then I plug that into the top equation to get 3x plus 8 equals 8. If you minus 8 from both sides, you get 0, so x equals 0. Final answer, 0, 2. On this equation, you can cancel out your y's by subtracting, because 6y minus 6y is 0. So 5x minus 7x is negative 2x, 4 minus 8 is negative 4. You get an x of positive 2. I plugged that into the top equation and ended up with y equals negative 1. So 2, negative 1 is the final answer there. This example is a little bit different because things aren't stacked up in the same way that all these other equations were. So the first thing that you actually have to do is stack your equations. So the first equation is going to stay just the way it is, as 8x minus 4y equals negative 4. And I'm rewriting that so that way when I manipulate this second equation, I can write it right in this space. So that way there's no separation. I want them stacked right on top of each other. So the other equation, to manipulate that, I'd have to minus 3x from both sides, but I also need that x term to come first and line up with the 8x. So that's a negative 3x term. The 4y is a positive term, and then it all equals 14. So now I'm ready to either add or subtract. In this case, I'm going to add because I have opposites. I have a negative 4y and a positive 4y. And so I end up with 5x equals 10, x equals 2. And then at this point, you could plug back into any of your actually 3 equations. This one never changed. And then you had this original 4y, or this one manipulated. You could plug into any of those. So if you plug that in, you're going to get, maybe if I plug it into the top one, 16 minus 4y equals negative 4. So then negative 4y equals negative 20. And then y equals 5. So I would end up with a final answer of 2, 5. So you can go ahead and try this example right here. First, you're going to have to stack your equations before you can add or subtract. Pause the video, press play when you're ready to check your answer. So the first equation, 9x minus 3y equals 18, doesn't change. But the second equation, you would add 7x to both sides, so 7x plus 3y equals 30. You're going to add those equations to get rid of your y terms, so 16x equals 48. You end up with x equals 3. If you plug that back into the original, 9 times 3 is 27, and then solve for y. Y also equals 3. So in these examples, what happens is if you actually just add the equations right away, you'd be adding 5x and 3x, and you would get 8x, or 2y and negative 4y, and you get negative 2y. So adding won't cancel anything out. And then the same thing with subtracting. You would end up with either 2x or 2 minus negative 4 would be 6y. So subtracting wouldn't cancel anything out. But what we can do is multiply either one or both of the equations to start the problem, and then hopefully set it up so that way we can add or subtract. So the easiest variable that I can get to match is my y's, because I can turn that top variable into a 4 by multiplying by 2. So I would get 10x plus 4y equals 32. And then I'm going to keep the second equation the same. 3x minus 4y equals 20. And I rewrite them both so that way they're just stacked right on top of the other. Now that they're stacked and the variable, the constants, the coefficients of the variables matches, at least in absolute value, now I can either add or subtract. So I'm going to add. So I would end up with 13x equals 52. If I divide both sides by 13, I get x equals 4. When it's time to find the y value, you can really go into either the original equation that you changed, the original that you didn't change, or the one that you did. I'm just going to put it into this 5x plus 2y equals 16. So you end up with 20 plus 2y equals 16. And then 2y equals negative 4. And then y equals negative 2. So your final answer would be 4, negative 2. So as long as you're multiplying by the exact same number all the way through, you're allowed to change an equation. And again, this one I multiplied by 2, but this one I didn't multiply at all. I didn't have to. So you're going to try these 2 examples right here. Pause the video, press play when you're ready to check your answer. So on this example here, I kept the top equation the same, and I multiplied the bottom equation by 3, getting 6x plus 9y equals 15. And then to eliminate, I subtracted. So you get negative 4y equals 4, and y equals negative 1. I put that back into this equation here. So I got 2x minus 3 equals 5, and when I solved it, I got x equals 4. Down here, I kept the second equation the same, the 4x plus 11y equals 9, and I multiplied the top equation by 2 to get 4x plus 2y equals negative 18. And then I subtracted, so 4x minus 4x went away. 11 minus 2 was 9y, and 9 minus negative 18 becomes plus positive. That's where the 27 comes from. So then y equals 3, and then I plugged that back into 2x plus y equals negative 9, and I got negative 6 for x. This first equation down here, so I can't multiply just one of the equations and get the coefficients to match. So this is a situation where you have to multiply both equations. But what's important to know is that you don't have to multiply by the same number. So your x's are 4x and 3x. So if you kind of think almost like least common denominator, least common multiple, the smallest number I could change those into and get them to match are 12, or 5y and 2y. I would shoot for a 10. It really doesn't matter which one you pick. So I'm going to multiply this top equation by 3, and I'm going to get 12x plus 15y equals 105. And then I'm going to multiply the bottom equation by 4, and I'm going to get 12x minus 8y equals 36. And then to eliminate the x's, I'm going to subtract. And again, this is just where you need to be careful with your signs. I actually just made this mistake. You're doing a positive 15 minus a negative 8, so that really becomes plus positive, so you end up with a positive 23y. And then you're doing 105 minus 36, so you end up with 69. Then if you divide both sides by 23, you get y equals 3. So then you can plug that back into any of your equations. So if I plug it into 3x minus 2y, I would get 3x minus 6 equals 9, 3x equals 15, x equals 5. So then my final answer would be 5, 3. So in this equation down here, there's actually a couple things going on. The first thing is that you have to stack, just like we did in the other one. So you want your x's and your y's and your equal signs all on top of each other. And then you'll also have to multiply both equations by different numbers to get your variables to match. So you're going to give this one a try right here. Pause the video, press play when you're ready to check your answer. So first, to stack this equation, I minused 5x, so that becomes negative 5x plus 9y equals 5. And then I multiplied this equation by 5, and this equation by 3. So then to cancel out 15x and negative 15x, you add. So negative 35y plus 27y is negative 8y. 25 plus 15 is 40, and then divide both sides by negative 8, and you get negative 5. I plugged that back in here, and I got x is negative 10. Try this example here, similar to the one on the previous page. Pause the video, press play when you're ready to check your answer. So 7x plus 4y equals negative 8 becomes this equation written so it's stacked under the other one. I chose to multiply by 4 and 3 to get my y coefficients to match, but you could have also multiplied by 7 and 2. That would have just found your y variable first. Either way, you should have come up with 0, negative 2 for your final answer.